All right, so today we're going to solve inequations with a variable in the denominator. Essentially, it has an x in a denominator and there's an inequality, okay? And we're going to use one method. In actual fact, there's about 5 different methods that you can use to do this, but this is the one that every year in the HSC, it says the students that use the critical values method or critical points method did way better and made way less mistakes. So that's what I want you to do, okay? So write this title, learning goal down. Okay, so we're going to get straight into it. What we need to do is, first of all, is that we need to put a number line in. Here, a number line is crucial, okay? That will be the basis of how we're going to develop our answers. I'm going to put a line there because I feel like we're going to need a bit more space. So, and this number line will be x. Now straight away we can pick the first, so this is critical values or critical points test. So the first critical value we can see straight away, and it's right here. X cannot be 3, okay? Why? Because the Cookie Monster gets upset, we get a 0 at the bottom of the denominator. Essentially what we're doing is that we're equating the bottom of the fraction to 0. X minus 3 equals 0, therefore x equals 3. So that's our first critical value. So what we're going to do is that we're going to put that somewhere in the number line. I'm not going to put a number line yet because I don't know what other critical values I'm going to get. So we're going to write x cannot be equal to 3. Okay, so that's our first critical value here. Is our first critical value, but in terms of our solution, x cannot be equal to 3. And now what we're going to do is that we're going to solve for, and we're going to make it to x minus 3 is equal to 1. So what we'll do is that we're making this an equality for the sake of getting the critical values, okay? So I'm going to take that off for the moment, all right? So we're solving for the sake of getting other critical values. So let's just solve it. I'm going to multiply both sides by x minus 3. So I get 2 equals x minus 3. I've just multiplied x minus 3 to there and x minus 3 to there, which cancels that out, okay? And now I can go therefore x equals 5. And all I've done is plus 3 there, plus 3 there, okay? So now I have my 2 critical values, all right? So I've got a critical value at x equals 3 and x equals 5, all right? Now I know something straight away. Okay, x cannot be equal to 3. So above the 3, I'm going to put a circle and it's not filled in, all right? But above the 5, I will put in filled in, and it's for one reason, and it's that this question has so it's greater than or equal to, okay? So or equal to, so we know that it's going to be that. And now what I have to do is I'm going to have to draw a grid, okay? So let's draw a grid. So here, I feel like I did too much, but it'll be all right. Yep. Okay. So what we're going to do is I'm going to go, these are values of x equals, so I'm going to make x equals, and then I'm going to put this in here. So 2 over x minus 3 is greater than or equal to 1. And then I'm going to go true or false, okay? So what I'll do is I will get rid of these other things because we don't need them, okay? So we just need a grid. We could probably extend these out a bit longer, okay? Yeah. Okay, so what we have to do is that we have to pick a value in this region, and then another value in this region, and then another value in this region. Now we've got to be strategic. We want to pick values that are easy, okay? Now value less than 3, so down this region, the easiest one is 0, okay? So I'm going to pick x equals 0. You can pick any value, it really doesn't matter. So I'm going to put x equals 0, and then I'm going to pick a number in this region, and it's pretty easy. I'm going to pick 4, but you could pick any number. You could put 4.5, 3.5, doesn't matter. And then a value in this region. So I'm just going to pick 6 because that's the next one that comes to mind, all right? And then I'm going to test if it fits this inequality, all right? If the equality remains true. Okay, so let's do it. So let's substitute 0 into it. So I'm going to go 2 over 0 minus 3. So that's going to be negative 2 over 3. Is that greater than or equal to 1? It doesn't seem to be because it's a negative number, so it can't be greater than 1. So this is false, okay? So what do we know? That the inequality does not exist in this region over here, okay? So it does not exist in that region over there. So that's all we're saying. All right? Now let's try in the 4. 2 over, and we're going to set 4 minus 3. So that's 4 minus 3 is 1, isn't it? Is that greater than or equal to 1? Well, that's going to be 2 over 1. So that's going to be 2 over... Is that greater than or equal to 1? Yeah, it is. So it's true. Okay? So that means that this value exists there. All right, so we draw a line. And let's just test the last value. It's likely that it's not going to be the case because normally we don't have it in subsequent regions, but sometimes we do. But yeah, so check that out. So let's try in 6. So we're going to get 2 over 6 minus 3 is greater than or equal to 1. 6 minus 3 is 3, so it's 2/3. Is that greater than or equal to 1? No, that's false. So it doesn't exist. So what it essentially is that graphically we've got our answer here. So we just need to sum it up with some sort of maths answer. So we go, therefore, x, it's a region in between. So x is going to be greater than 3, but not equal to. But it's going to be less than or equal to 5, okay? Which is exactly the same as what we're showing there. So this is solving with the denominator, with a variable in the denominator. Now I want to show you how it looks in Desmos. So let's bring this up and let's do this. So Desmos can do inequalities, and I've actually already done it there. I'm going to take, that's the next example up there, off. Let's put that up. So yeah, we've got both of them working now. So I'll bring that down. So that's the inequality there. And we've said that it's in between 3 and 5. And notice, obviously I can't write on Desmos because it's not part of the note program I've got here. But notice there's a dark line over the 5. That means that it's equal to that line. And there's no dark line over the 3, and that because it's not equal to. But that region is the one that works. Anyway, I hope this helps. Yeah, so this is solving inequalities using critical values methods. Peace out.